In lessons 7 and 8, we talk about rate of change and then slope. And it's kind of confusing because usually when we have two different names for different things, they mean we're doing different things. But in the case of rate of change and slope, they are the same thing. So rate of change is the same thing as slope. And really it just means you're doing the exact same thing to find them. Sometimes it's more slope that we talk about if there's a graph, and maybe more rate of change if there's a table, but really you are doing the same process for both, and so they're kind of interchangeable in that sense. So it says the table shows the number of pages Adriano read in X hours. Graph the data, then find the slope of the line. So the first day in 1-7, you were looking at the table and finding the rate of change. Well, I'm sorry. There. The rate of change looks at how one quantity is changing in comparison to another quantity. So we're looking at how time changes with the page numbers, or the number of pages. So when I look here, going from 1 to 2, we added 1. From 2 to 3, we added 1. From 3 to 4, we added 1. Now, it won't always be that case, but in this case, it was always adding 1. And in some cases, you might actually be subtracting even. It's going to be adding or subtracting. Here, the number of pages goes up by 50 every time. So to find your rate of change, you would look at from one amount to the next amount. So from the first one to the second one, we see that it changed 50 pages in 1 hour. And we're going to say 50 pages per 1 hour, or per hour, is our rate of change. Now, since the rate of change from the second to the third is also 50 pages per hour, and from the third to the fourth is also 50 pages per hour, this is when we say we have a constant rate of change. Because notice, as an hour is added, we also add the same number of pages every time. Now, it could also be a constant rate of change if I did something like this and added 2, and then since I was adding 2 and doubling this amount, I would also have to double that amount and add 100, and that would keep my constant rate of change, because 100 over 2 hours would still be 50 pages per hour. So that's how you find your rate of change when you're looking at a table. When you are looking at a graph and you need to find your rate of change, you're going to plot your points. So time is our x, y is our page or number of pages. So we would have 1 hour is 50, 2 hours 100, 3 hours 150, 4 hours 200. And you make a straight line because our rate of change, since it told us with the slope, we're doing constant rate of change right now, and notice it's constant. We already figured that out. We know it's going to be a straight line and continue on with the same pattern. And just a reminder, this is a proportional relationship because remember, it's a straight line going through the origin, so that means it's proportional. From here, once you have your graph, you would pick 2 points. It doesn't matter which 2. So let's say I'm going to pick this one and that one. You have to see how both the number of pages and how the time changes from one point to the next. So number of pages, since that's going up, we have to see how much it goes up. Well, it goes from 50 to 200. So I know it went up. I'm going to write plus 150. Then we have to see how far it went that way. Well, notice even though it still went 3 boxes, it's not 150 because it went from 1 to 4, so it moved 3. from there, you would do the exact same thing. It's always your y over your x, or in slope, we like to say rise over run. And remember, slope is the same thing as rate of change. And from here, you would always put your rise, how much you go up or down, over how much you run, how much you go left or right. And so you'd have 150 over 3. And when you simplify that to your unit rate, we would have 50 pages in 1 hour, which is the exact same as what we had up here. So you can find it from the table by adding every time, or you can find it from your rise over your run. I'm going to show you that very quickly on another one, just in case you want to see another example. So here, okay, we're adding 1 every time. Here we're adding 3 every time. And so it would be 3 feet in 1 yard, or 3 feet, 3 number of feet for 1 number of yard when we look at this. And that is our unit, or that is our rate of change. Now, in both of these cases, we have a rate of change that's the same as our unit rates when we look in the table. That does not have to occur. You might get a table sometimes that looks like this, and say maybe we have 18 and 2, and then 24 and 4, and then 6 and 30, and then 36, and 8. Okay, when we look at this, 18 divided by 2 is 9. And then we do 24 divided by 4, and we get 6. So notice the unit rates are different already, but our rate of change is every time we add 2, and up here every time we're adding 6. So here our rate of change is 6 over 2, or 3 over 1, and that doesn't match up with the unit rates. So don't always think you can just take the numbers inside and divide them. You have to look at how the numbers are changing, going from one to the next, one to the next, one to the next, and then on the other side, one to the next, one to the next, one to the next. In this case, you would find it the same way on the graph then as you did up here. 1, 3, 2, 6, 3, 9. We have our line. You pick 2 points. Now, I'm going to make a suggestion. I would, if the line goes through 0, 0, because you have to pick points on the line, I would pick 0, 0, and then another point. It makes it really easy to see how much it rises then, because you go to that number, it rises 3 and goes over 1. So it would be 3 over 1. If you picked 2 different points, it would still work. Maybe you picked this one and that one. Well, there I would rise 6 and go over 2. 6 over 2, that's still equal to 3 over 1. So it doesn't matter which 2 points that you pick. And that's the basics of this lesson. A couple things that you need to know, though, is it might ask you to explain what points mean. Well, on this case, if it asks you to explain what 0, 0 means, it means in 0 hours you travel 0 miles. Maybe if they asked you that one, it means you traveled 3 hours, or I'm sorry, at 3 hours you traveled 180 hours. And the last one that they might ask you is maybe 1 and 60, and that means in 1 hour you travel 60 miles. And there's something special about that. That is also our unit rate. Remember, a unit rate is when the bottom number is always a 1. It doesn't matter what's on the top, but the bottom number is always 1. And when we go to look at this with our slope, we always compare the change in miles, or change in your y-axis, over your change. So I guess that's not a good, let's put a question mark. I don't want to confuse you. So it's always your change in your y-axis over your change in your x-axis. And so wherever that x value is a 1, that's going to be our unit rate. So anytime you have a graph, wherever the 1 is on the x-axis and you go up, that's your unit rate. So when we look down here, this would be our unit rate because it's 130. When we look over here, our unit rate would be 150. This one, 1.3. The unit rate is always where that x value is a 1.